Hi guys, this is Don. I'm going to take a few minutes to show you how to solve a chi-square goodness of fit problem using good old plain old Excel functions. And this is a problem that has to do with residential and commercial coal consumption. And we're given the monthly consumption for a number of months there. I haven't counted it yet. We'll have to do that. But we're getting the monthly values in thousands of BTU. The company that is doing this says that the consumption pattern is uniform, which is surprising given that normally you have a seasonal, but that's their claim, that it's uniform. So if it's uniform, what we need to do is to find out the average consumption is for all these months and then apply that average as our expected value. So I'm going to call this expected, and I'm going to calculate the average and select that first cell, and you can use the Control Shift down arrow to get you down to the very bottom, and that gives us a value per month of 11.5, and we want to copy that down. So I'm going to just go Control C, highlight that, and I can again use the Control Shift down arrow. Whoops, that didn't work. Okay, what I want to do is copy this first value there, Control C, and then I want to copy it down. I'm just going to drag this down to the very bottom. Can't use the Control Shift down area because there's nothing at the bottom to stop it. So we keep going down there. There we go. And I want to paste special. I just want to paste the value, and we've got our uniform distribution now. So what we want to do is to first of all count or calculate the degrees of freedom. Degrees of freedom for goodness of fit is the number of values minus 1. So I'm going to use the equal count function. Double click that to select it, and now I think I can use the Control Shift down. I can, to give me my count. What I've got to do though is to subtract 1 from that. Remember that our degrees of freedom is the number of items or categories minus 1. So that gives me 131 for my degrees of freedom. And with that, I was able to get my answers here. I'd already set up the formulas. The first thing I did, I solved for the p-value, the probability that we would get these values are more extreme, and it tells us that this is a significant test. We would reject the null, and we got the p-value using the chi-square test, chi-square q-test, I guess, and it takes as its values the observed, which is in the column B, and the expected, which was in our column C, and returns the p-value. Once we get the p-value, we can calculate some other things, but most of your problems you need to calculate the critical value, and you can also calculate that from using a Excel function, and it's the chi-square inverse right tail. Remember, for the goodness of fit, we're using right tail test, and it takes as arguments alpha and the degrees of freedom. So in this cell, I just put equal chi-square dot inverse start right tail, and put in alpha, which was D3, and degrees of freedom, D4, and it returned a critical value of 152.195. And just for fun, I have to have a chart, you know me, and I did the chart using StatCrunch, putting in the degrees of freedom, the alpha, and getting again 152.125, the same value. But we've got our nice sketch there that shows our right tail, again always right tail, rejection region, any value of our test statistic chi-square greater than 152.125. Okay, we can calculate our test statistic using the chi-square inverse.rt function again, but this time instead of putting alpha in, we put our p-value. We've calculated p using the chi-square.test function, put that p in there, and it returns our test statistic of 191.921, which is well within, if we go back here to our graphic, 191.1 is way over here, so we're definitely in the rejection zone, and that would explain why we've got such a small p-value and we reject the null. And that's how you do it using simple functions in Excel.